Hi guys, I'm going to do a video today about the different kinds of 3D shapes that we've been talking about in class. So this is kind of like a summary video of the features and names of different 3D shapes. Okay, I'm going to go through some vocabulary as well. So let me turn. Alright, so a couple of things to bear in mind with what I'm going to be talking about today. We've got different types of vocabulary that are associated with different numbers when we're talking about 3D shapes. So tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca is 10. These ideally would be in order in your book. Okay, so three words that I'm going to be using a lot of today, often today, edges, so where two faces meet. So if I've got my shape here, I'm talking about this face meeting this face, and this is the edge, okay, along here. Faces, so they're the flat 2D parts of the shape. Some shapes will have more than one kind of 2D shape face. Others will have them all the same kind of shape. Okay, we'll talk about that. And vertices are the corners where three faces meet. So 1, 2, 3. That's one vertice. Okay. All right. And then we've also got two broad categories of shapes. Okay, we've got a prism, which is two of the same 2D shape on the ends with rectangular sides. So I've got an example here. I've got a hexagon on this end and hexagon on this end, and in between for this shape there are rectangles as the faces. Okay, you could also have them as squares if it was a little bit more squashed. Okay, and they were all the same size. I'll just make this a little higher. Cool. So they are what we call prisms. A couple of ways to remember that kind of shape when you say the word prism is that it's like a prison, like a jail. Okay, so you would have the same size walls, I guess, of your prison compared to a pyramid. And also, if you were to slice it like a loaf of bread, you would have the same size of your end wherever you sliced it. Okay, so that's a prism. So that's an example there of a prism. We've also got this one here. Okay, so triangles on the end, rectangles along the side. All right. The other kind of broad category of shape is a pyramid. Okay, so we've got a different base sometimes, and then the key difference is there's triangles that lead to a vertex up the top. And we usually name those pyramids depending on the type of shape that's on the bottom. All right, but we'll get into that in a moment. Okay, so I'm going to talk about the features now. So I'm going to have the name of the shape, and then the features. We're talking about faces, edges, and vertices. And I'm going to try and do that for 8 shapes here. So we'll see how we go. Okay, so the first, I'm going to talk about the net as well, which I'll get to in a second. So the first kind of shape we've got, we call a cube. Now the features of a cube is that it has 6 faces all the same, and they are squares. Okay, and it has 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay, and then we've got edges. 1, 2, 3, 4. Same on the other side. 6, 7, 8, 9. Sorry, 5, 6, 7, 8. God, I can't even count. 9, 10, 11, 12. Okay, so for our cube, we have 6 faces, and they are squares. Okay, vertices I did next, didn't I? 8, and edges 12. Okay, rightio. Now let's quickly talk about the net whilst we're doing this. So with these shapes you can pull out the net, which is really handy. Now I don't know if I'll be able to get this in the one picture. Let's have a crack. Oh, it's too big. Anyway, let me see if I can make this camera a bit higher. That helps a little bit more. Okay, cool. So when I fold these out here, I've got my 6 faces, my 6 squares, and the net traditionally is a picture of what the faces of the shape would look like in the arrangement that would suit me to be folding it back up together and have it go back to its original shape. So if you just drew like 6 squares on a page to say that that was the net of a cube, if they weren't arranged to be connected in a way that they could be folded back up, then you haven't correctly drawn a net. So for a cube and any of our prism shapes, you could actually have a couple of different varieties of nets, okay? So if you moved these 2 down, they would still work if you folded it back up like that, for example. Okay, that's our cube. Okay, going through the rest of the prisms now. Okay, we've got, before I go on, this can also be called a hexahedron, and that word means same 6 faces. So because our cube has the same 6 faces of squares, it can be called a hexahedron. Okay, hex for 6 or hexa for 6. Okay, now we've got a square prism. Okay, so because the ends are square, you can have a square prism. So folding it out. Okay, we've got our 2 squares here, and these are rectangles, so slightly different to the cube. Okay, but if you're really clever, you'll realize that all of that information is the same. So there's still 6 faces, there's still 12 edges, there's still 8 vertices. The only difference is that it is squares and rectangles for the types of faces there. Okay, moving on. Getting a little different now. Okay, we've got a triangular prism. Triangular prism, okay? So meaning we've got triangles on our ends, and then in between there are 3 rectangles to bring it all together. Okay, so we've got faces 1, 2, 3, 4, 5. So remember, just because you can't see them doesn't mean that they don't exist. Okay, so still count the things on the bottom, for example. Edges 1, 2, 3, 4, 5, 6, 7, 8, 9. Vertices 1, 2, 3, 4, 5, 6. Okay, good progress here. All right, so this one here, I've got a hexagonal prism because I've got hexagons on each end. Okay, so similarly, you could have a pentagonal prism. For some reason, I don't have a example of that, but it would be pentagons on each end with rectangles connecting them. Okay, so hexagonal prism. Okay, faces, edges, vertices. Okay, so faces 1, 2, and then 6 rectangles, so I've got 8 faces in total. Okay, my edges, let's make sure I get this right. So 6 on the other side, 1, 2, 3, 4, 5, 6, so that's 12, and then 6 in between here as well, so 18, and my vertices 1, 2, 3, 4, 5, 6, and then 6 on the other end, so 12. Cool. Quick look at the net. Okay, so again, this is one of those scenarios where you can have like the hexagons could move down a little bit, and that would still fold up correctly as well. Cool bananas. All right, so they are our prisms. I'll just do a different sheet for my pyramids. All right, so we've got a square-based pyramid here, okay? Square-based pyramid. Exactly what it sounds like. The base of it is square and it leads up to a vertex at the top, so it is a pyramid. Okay, so we've got faces, edges, vertices. Faces, we have 1, 2, 3, 4, 5. Edges 1, 2, 3, 4, 5, 6, 7, 8. and vertices 1, 2, 3, 4, 5. Cool, let's take a look at the net. Alright, so an interesting part about the pyramid is that, pyramid net I should say, is that I can't see a way that this can be drawn differently and still be able to be folded up into this shape. Okay, so you couldn't move the the square base to another part, okay, with it being able to make a net. So that's a key difference between pyramids and prisms. Alright, moving on a little bit more. This can be called a triangular, so here if we can say this is the top, I guess, but the bottom is the same. So we've got a triangular base pyramid, but what a better word to use would be a tetrahedron. Okay, so before, when I talked to you about the hexahedron, which is known as a cube, we had the same and then hexa for 6. Here we've got tetra meaning 4, hedron same. Okay, so my 4 faces, 1, 2, 3, 4, are all the same type of shape, the triangle. Okay, that's why it's called a tetrahedron. That's the word I would prefer you to use. Okay, faces, edges, vertices. Okay, faces on this shape, 1, 2, 3, 4, edges, 1, 2, 3, 4, 5, 6, vertices, 1, 2, 3, 4. Cool. Okay, so I'm going to do these two together because I'd like this video to not be super duper long. Okay, so these are both pyramids here, but if you flip them over, we've got a pentagon on the bottom, okay, and then this is a hexagon. So pentagonal based pyramid, hexagonal based pyramid. Okay, so let's just do the pentagonal based pyramid in terms of information. Pentagonal based pyramid. Cool. Okay, so faces, we've got 1 on the bottom and then 2, 3, 4, 5, 6. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And vertices, 1 and 5 on the bottom, 6. Cool. So guys, you don't have to, oh sorry, I'll show you the net, just it's pretty similar to the others, but always good to look at. This one doesn't want to come out. Okay, so here's an arrangement that we haven't really seen before. So with the tetrahedron, we had the triangle in the middle. This one here, you've got the hexagon there, and then the triangles that lead to the pyramid part at the top. So in this case, you can rearrange this net. So if this was here, it'd be very similar. It would be able to make a net, but you wouldn't be able to put the hexagon up here. Okay, that would not work for a net. Okay, so I'm not showing you this video, guys, so that you can memorize all of these features and remember exactly how many edges a square-based pyramid has. Okay, what I need you to do for this is to really recognize and understand what is the face, what is an edge, what is a vertice, and also where the names, what the names actually mean. Okay, so if it's a pyramid, it's going to have the triangular sides with the base either a square or a triangle or a pentagon, for example. If it is a prism, okay, we're talking about the ends being that sort of a shape with rectangles or squares joining them all together, like a loaf of bread. Okay, so that's the key things I need you to take away from this, and then you should be able to visualize that shape if you're asked to provide information about the faces, edges, and vertices. Okay, good luck.